Hey, it's me, it's Mr. Miller. I'm back. We're going to be talking about our measuring volume part 1 notes, so let's go ahead and get started. Measuring volume. We use something called a graduated cylinder to find the volume of liquids and objects. This is a graduated cylinder here that I have in my hand, and this is what you'll be using. They are glass. You'll have to be careful. Now, when we go to find the volume of a liquid, we have to know something called a meniscus. A meniscus is defined as the curve at the surface of a liquid, and you can kind of see that up here in the box. That liquid takes a little bit of a curve in a glass graduated cylinder. You want to measure from the very bottom of that curve to get the most accurate measurement. Make sure you read it on a flat surface and at eye level, because if not, that will throw off your results. So what do you think the measurement is, the volume of that water is in the cylinder right now? Well, starting here, there's 40, 41, 42, 43. If you said 43, you are correct, 43 milliliters. Now, you get to determine the volume of the water in this graduated cylinder in milliliters. Take a look. There's the curve at the surface, right there. There's the curve. See where it's touching? What do you think it is? Alright, if you said 18 milliliters, then you are right, and you are starting to understand how to read the volume in a graduated cylinder using the meniscus. Next comes the fun part. Yes, this is using some math in science, where we have to learn how to calculate the volume of an irregular solid. An irregular solid is, say, something like this whiteout container, or this pen. It's something that doesn't have a specific length, width, or height. Even just like this, a paper clip. These are objects that we have to use something called the water displacement method. We simply pour some water in here, we put the object in, and we find out how much the object displaced the water, how much the water came up. That's called the water displacement method. Alright, so when measuring an irregular shaped object like a rock or a marble, anything like that, we can measure the volume using the water displacement method. And this equation right here called VF minus VI. That stands for final volume, VF, minus initial volume, VI. Initial meaning what you started with. Alright, so let's take a look at these two graduated cylinders here. The amount of water without the object is this right here. We're going to say that that's 200 milliliters. Now I put my rock in there and I measure how much the water was displaced. How much did the rock push up the water? Well, that pushed it up to 260 milliliters. Now I take VF minus VI, so my final 260 minus the starting, the initial 200, and I subtract them. And I get 60 milliliters is how much the water went up. I want to know the volume of the object. I have to convert it to 60 centimeters cubed. Milliliters only measures water. Centimeters cubed measures the volume of an object, a solid object. That's why I have to convert it. Okay, now how to calculate the volume of irregular solids? Pretty simple. Fill a graduated cylinder to 50 milliliters. Carefully slide the object into the water. Subtract the final volume from the initial starting volume, like we just did. Convert milliliters to centimeters cubed to find the volume of the solid. Why? Because 1 milliliter equals 1 centimeter cubed. They're actually equal. So what that means is a cube like this, 1 centimeter by 1 centimeter by 1 centimeter, will cause water to go up exactly 1 milliliter. And I will show you in class, in this chapter, I'll have a little 1 centimeter cubed, I'll put it in there, and it will go up 1 milliliter. That's why I can do that. Alright, Mr. M steps to math work. Oh yes, I have certain steps that you have to write out. I want to make sure that you understand the process, that you're just not writing things down. So this is how we do it. The first thing you will do is you write out the equation. Second, you write answer equals question mark, and I'll show you what I mean by that in just a minute. 3, you list out all the numbers. 4, plug in the numbers to your equation. 5, show all your long math work. There are no shortcuts. You have to show your long math work. 6, write your answer out, and then 7, finally circle the answer so I know which one you want me to grade. Make sure it has the correct units with it. So let's do an example so you can see one. Alright, this is how you would set it up. You write V equals question mark because that's what you're solving for. We don't know the volume of the object just yet. this is what I mean by equation. This is what we're going to use to solve the problem. V equals Vf minus Vi. This is where you write out what everything is. So Vf, that's my final volume. I come over here and I look. It's 75 milliliters. So I write Vf equals 75 ml. What did I start with? 50. So I write 50 ml for Vi. Now I plug those two numbers back into this original equation down here. V equals 75 minus 50. Show your long math work here, so you actually subtract out 75 minus 50 and you'll get 25. V equals 25 milliliters. Remember, that's how much the water went up. I have to convert it to V equals 25 centimeters cubed so I know what the volume of that rock is. And then I circle the final answer so I know what to grade. That's how you do it. And once you do one or two of these, it becomes pretty easy. And most sixth graders will tell you, it's not that hard. Once you do a couple of them, it's pretty easy and it actually helps you. So let's do one together here. Here's a practice one. Let's take SpongeBob. Let's try to squish the square SpongeBob here into the container and see what we get. So we're going to solve for his volume. So V equals question mark. All right, so we have to write the equation. What's the equation? V equals Vf minus Vi. Next, you're going to tell me what is the final volume. Well, come over here and you'll look. We started at 50 and he went up to what? Well, this is going to skip by 2's. That's 2, 4, 6, 8, and then there's 60. So it's 52 is my ending volume. And then what did I start with? 50. So I plug that in. Then I have to take those two numbers and put it back into this equation right here. V equals 52 minus 50. Now show your long math work. So take 52 minus 50 and you're going to get 2 and then put V equals 2 milliliters. That tells me how much the water level went up, but I don't want to know what the water level was. I want to know what his volume is, the object. That's where I convert it to centimeters cubed. Why? Because centimeters cubed is what we use for the volume of solid objects. So of course your answer would be V equals 2 centimeters cubed. Circled the final answer so I know what to grade. Okay, that's how you do the volume of an irregular shaped object. We'll practice some of this in class. All right, see you soon.
Hey, it's Mr. Miller. Today we're going to talk about reading a graduated cylinder. First thing first, this is a graduated cylinder. This is one that we're typically going to use in our classroom. It's a glass 100 milliliter graduated cylinder. What I want you to remember, number one, always keep it on a flat surface. All right? So put it on our table, typically in the center of the table. We don't want to put it over on the side or even close to the edge where it could get knocked over. So try to keep it in the center of the table, away from the edges. So number one, keep it on a flat surface. Number two, you need to always read it at eye level. What you don't want to do is pick it up like this and try to read it, because reading it like this is going to give you a different angle. If you're sitting down and looking up at it, it's going to give you a false reading. If you're standing up and you try to read it, you're looking down on it. So again, it's got to be on a flat surface all the time. Third thing you need to remember is to read the meniscus. What is the meniscus, you ask? Well, let me show you. The meniscus right here, as you'll see back here on the smartboard, the meniscus is the curve at the surface of a liquid. That liquid forms a small curve, and what you want to do is read the bottom of it. So you have to read it at eye level. And I always tell kids, how do you read at eye level? Remember the Get Down On It song. And if I just click this off real quick here and push this, and we are ready to go. And you just get down on it. And you just keep going down until you get eye level, and then you can read the bottom of that meniscus. And if I bring that right up to this camera, you can kind of see right there. There's the bottom meniscus at 50 milliliters. All right. Now, in our classroom, what I want you guys to do is anytime we need to measure, fill it up to the 50 milliliter mark. And again, make sure you get down on it and that meniscus, the bottom of that curve, is right at 50. Then we're ready to actually take our measurements. Now, we don't want to just drop the object into the graduated cylinder because then water is going to splash out and that's going to throw our results off. So what you want to do is carefully kind of tilt it to the side, take your object, slide it in, and then tilt it up. Then you'll find your final volume by reading the bottom of the meniscus after the level has gone up. That's how you read a graduated cylinder.